So if you were in class today, we'd be playing the unfair math game. So I can write an equation from a story problem. I can determine the constant proportionality given a story problem. And I understand that unit rate and constant proportionality are synonyms. Remember, synonyms mean the same. So Sherwin worked for 27 hours and he earned $324. How much did Sherwin earn per hour? So I'm going to need to pull up my calculator. Alright, so I'm going to start by making a table because I have to figure out how much he earned, he earned per hour. So I know that I have hours, and I know that I have money, and I know it was 27 hours for $324. And I want to figure out how much did he earn per hour. So that means for 1 hour. So I'm going to divide by 27 on each side because 27 divided by 27 is 1. So my calculator, I have 324 divided by 27, and I get 12. So how much did he earn per hour? $12 per hour. A banquet hall charges $110 to rent a room for 4 hours. Which equation could be used to determine C, the cost for X hours of use? Well, I have to find out how much it is for 1 hour of use before I can do anything. So I'm going to make myself a table. I know that the hours, but hours is X, so I'm going to put in X here. And up here I'm going to write hours, so I know what I'm doing. And then the cost is C, and I'm going to put the $sign up there. So I know that it was $110 for 4 hours. I need to figure out what it is for 1 hour. If this doesn't get me the equation I want, I can always move the 1 to the other side or the other column. So I can divide by 4, divide by 4. So I'm doing 110 divided by 4, and I get 27.5. So I know that 27.5 times the X column is going to give me the answer in the Y column. So 27.5X equals C. So 27.5X equals C. So my answer should have been C. John paid $80 for 5 tickets to the amusement park. Each of the tickets cost the same price. Which equation could be used to find C cost for N tickets? Alright, so I'm going to make a table. And I know that I have N, and I'm going to write tickets up here so I know what I'm doing. And cost, so that's money. So I know 5 tickets cost $80. To write an equation, I need the constant of proportionality, so I need the amount for 1. So I'm going to put a 1 there. I'm going to divide by 5, because 5 divided by 5 is 1. 80 divided by 5 is 16. So I know the cost for 1 ticket is $16. So 16 times the number of tickets is going to give me the cost, because 16 times 5 is going to be 80. So 16N equals C. Now, if that equation wasn't there and I couldn't use it, I might decide to add a 1 in the other column, because remember, you can have 2 constants of proportionality. I would divide by 80 this time. So 5 divided by 80, and I get 0.0625. So this time I know that this times the cost is going to give me the number of tickets. So my other equation could be 0.0625 C equals N. So sometimes when I have multiple choice questions and I have to choose the equation, I might have to switch around where my constant of proportionality is. So either one of those equations would get me the missing value. Charlie drove 208 miles in 4 hours at a constant speed. He continues at that speed. Write an equation that shows the driving hours, H, and the miles driven, M. So I'm going to draw myself a table. So I know I have hours and miles. So it's 208 miles in 4 hours. I have to figure out what it is for 1 hour. So I'm going to divide by 4 and divide by 4. So 208 divided by 4, I get 52. So I know 52 times the number of hours is going to give me the miles, because 4 times 52 is 108. So my equation would be 52H equals M. Or I could do M equals 52H. It doesn't matter. LaShonda purchased 42 gallons of gas for $121.38. That must have been like a truck or something, because my car or my SUV won't hold 42 gallons of gas. Write an equation that represents the cost Y of X gallons of gas. So I'm going to make myself a table. I know that the cost is Y, and I know that the gallons is X. So the reason why I label my columns is so that I know where to put the numbers from the original problem. So it was 42 gallons of gas, so that has to be the X, and the cost was $121.38. So I want to find for 1 gallon of gas. So I'm going to divide by 42. I'm going to divide by 42. So 121.38 divided by 42 is going to be 289. So I know 289 times the gallons of gas is going to give me the cost. So Y equals 289X. Now let's say I put the 1 in the wrong column when I'm solving it. Then I can just move it to the other side. So I could always add a row and put my 1 in, divide by the opposite sides, and then come up with the other equation, because all tables have 2 equations. All right, Adrian's pay is calculated using the equation P equals 25H, where P is the total pay and H is the number of hours worked. Mitch is paid $32 per hour. How many more hours will Adrian have to work than Mitch to earn $1,000? Okay, so they're giving me the constant of proportionality in the equation, so it's 25, right? So he makes $25 per hour. So Adrian he makes, so I'm going to put hours, I'm going to put money, right? So in 1 hour, he makes $25. So they want to figure out $1,000. So I have to get to 1,000. So I'm going to have to add a 1 to the right-hand side, because I'm trying to figure out how do I get from 1 to 1,000. And then in the other person, I know Mitch made in 1 hour $32, and I have to figure out the same thing, how long it's going to take him to get to $1,000. So I'm going to use my table to my advantage. I'm going to figure out what it is for 1 hour, or I'm sorry, not 1 hour, $1. So So my calculator, 1 divided by 25. Oops, hit the wrong button. 1 divided by 25. Did it again. There we go. Okay, I get 0.04. So now I have to get from, 1 to 1,000. So I'm going to multiply by 1,000. So on this side, I'm going to multiply by 1,000. So I know times 1,000. And I get 40. So it's going to take him 40 hours to earn $1,000 because it's in the hours column. So 40 hours to earn $1,000. So now I have to figure out the same thing for Mitch. I should probably put his name at the top. So I divide by 32. Divide this side by 32. So 1 divided by 32, I get 0.03125. I'm not going to round in this case because it's not one of those crazy numbers that goes on forever. So I'm just going to stop where I'm at, where it is in the calculator. All right. And then I have to figure out what it's going to be for 1,000. So I'm multiplying by 1,000 on each side. I must have done something wrong. Let me try again. 1 divided by 32. Okay, 31.25. So it's going to take him 31.25 hours to earn $1,000. But they want to know how many more hours will Adrian have to work. Well, how many more, I remember from elementary school, tells me I have to subtract. So I have to take the 40 and the 31.25 to figure out how many more hours. So I'm going to subtract 40 minus 31.25. And I figure out it's 8.75. So if I have to round to the whole hour, it's going to be 9 hours. So even though Adrian's only making $7 less per hour, it's going to take him 9 extra hours of work to make up for the same amount of time that Mitch takes for $1,000. All right, they want us to write an equation that correctly relates the price of cereal with the weight. So I'm going to make myself a table. So they're doing P for price, and that's in dollars. And they want the weight, which is in ounces. So 12 ounces of cereal costs $3.60. I want to figure out what 1 ounce is going to cost me. So I divide by 12. I divide by 12. So 360 divided by 12, I get 0.3. So 30 cents times the weight, and I know it's got to be cents because it's money. Money has to have 2 places behind the decimal. 30 cents times the weight is going to give me the price. So my equation would be 0.30 times the weight equals the price. Now, let's say I put the 1 in the wrong column and I wanted to, and this equation wasn't in the multiple choice section. I can always add a row and change where I put the 1 and do the same steps again. Divide by $3.60 on each side. All right, on a map of North Carolina, 27 centimeters represents 18 miles. Based on the map, write an equation that would calculate the number of miles between 2 cities, where y, the number of miles between the 2 cities, so that's y, and when they measure x centimeters apart. So I'm going to draw my table. I have x, and that's the centimeters, and y, that's the miles. And I know that it was 27 centimeters equaled 18 miles. I want to figure out what it is for 1 centimeter. Now, again, I can always put the 1 in the other column to come up with the second equation. So divide by 27. So 18 divided by 27, order matters. I get 0.6 repeating. So my equation would be 0.6 repeating times x is going to give me the y value. So 0.6 repeating times 27 is going to give me 18. All right, for this one, the table below shows the cost of tomatoes at Roger's store. If C equals 2P describes the cost of tomatoes at Lisa's store, where C is the cost and P is the pounds of tomatoes, which store has a better deal and by how much? All right, well, I'm going to have to add a row to this one to figure out how much it costs for 1 pound of tomatoes, because you're always comparing how much it is for one. So I'm dividing by 3, dividing by 3. So 7.35 divided by 3, I get $2.45 per pound. So now I've got the same thing here, and they gave me my unit rate, which is $2 per pound. So where is it cheaper? It's cheaper at Lisa's store. Right? Because if it's only $2 versus $2.45, and it's cheaper by 45 cents per pound. And I know it's cheaper by 45 cents per pound because I can do $2.45 minus $2 and I get 45 cents. Alright, a 14-pound bag of dog food costs $16.24. A 30-pound of dog food costs $33.30. Which statement is true and can be used to determine the better buy? So the better buy is always cheaper. So I'm going to make myself a table, and I'm going to have to make it small because my space is really small. Oh, I didn't mean to do that. I meant to do that. There we go. Okay, so I know that I have pounds of dog food and I have cost. So I know that 14 pounds costs $16.24. I want to figure out what it is for 1 pound of dog food. So I'm going to divide by 14. On that side, so I'm going to divide this side by 14 to figure out what the cost is for 1 pound of dog food. So $16.24, because order matters, divided by 14 gives me $1.16 per pound. Oops, I didn't know that happened. Oop, oh goodness, what did I do? Oh, I see what I did now. Alright, so then I've got to figure out the other one. So I'm going to use, so I know my pounds and my cost. The other bag is 30 pounds for $33.30. Now remember, you want to put the 1 in the same column when you're comparing, because you want to compare pounds to pounds or cost to cost. You don't want to switch it around. So I'm going to put the 1 in the left-hand column because that's what I did in the first one. Okay, so I'm going to divide each side by 30. There's a lot of things I like about Keynote, but that is not one of them. Divide by 30. So $33.30 divided by 30 is going to be $1.11. So I know that the cheaper one is the 30-pound bag. So if I look at it, it says the unit rate of the 14-pound bag is 5 cents less. Well, that's not true. The unit rate of the 14-pound is 5 cents more. Well, 11 cents to 16 cents, it is 5 cents more. So I think it's B, but I'm going to read all the options because sometimes I read it wrong. The unit rate of the 14-pound bag is 50 cents less. Well, that's not true because $1.16 minus $1.11 is only 5 cents. So that's out. The unit rate of the 14-pound bag is 50 cents more. No, it's 5 cents. So I was right. It is B. Last one we're going to do today. One printing machine printed 500 books in 40 hours this week. A second printing machine printed for 30 hours but printed the books twice the hourly rate of the first machine. How many books did the second machine print this week? Okay, well, I have to figure out the hourly rate for the first machine, so I'm going to start there. So I know hours and books, right? So they got 500 books in 40 hours. And they want the hourly rate, so I know that I have to put the 1 in the hourly column. So I'm going to divide by 40. And I'm going to divide this side by 40. So in my calculator, I'm going to do 500 divided by 40. And I get 12.5. So they can print 12.5 books in 1 hour. That's what that means. So they say the second printing press can do twice the hourly rate. So that means that I'm going to make another table. Choose a different color. Okay, so I have my hourly rate and my books. So twice that would be 1 hour would be 25 books because 12.5 times 2 is 25 books. So I need to figure out 30 hours. So 30 goes in the hours column. So I'm going to multiply by 30. So I'm going to multiply this side by 30. So 25 times 30, and I get 750. So it says how many books did the second machine print this week? 750 books. All right, if you have any questions or you're struggling at home, please let me know. I'll be glad to do a more personalized screencast for you or talk to you or figure out how to help you understand because I know it sucks to be at home. Let me know, and I hope you have a great rest of your day. Bye.